And this begins EE 569 on Tuesday, October 1st, 2013. Excuse me. Ready to start.
Can I have the computer screen? Okay, let's start with the discussion. First, I have some announcements regarding your grades for homework 1. Then we'll go over hints for homework 1, hints for homework 2, and finally I'll discuss some sample midterm questions. So the grades have been uploaded on DEN. I'm sure you might have already checked it. So there are 3 columns, or sorry, you won't be seeing the columns. You'll be seeing 3 values for the first homework. One would be the raw scores, which is equal to the on-time submission score plus the late submission score. And then the other column, the other value would be whether you have a late submission or not. This does not tell you of how much grades or what is the portion of the entire assignment which was late submitted. Finally, there is a location for penalty score which we have not applied yet. It will be decided at the end of the semester. So, and you can also download the graded reports. Problem 1 and 2 were graded by VHAW, and problem 3 was graded by the second grader. So you can download both the graded reports from DEN. Graders will hold office hours on Thursday. The office hours would be held in EEB basement. So you can just go there. But there is one requirement: you have to bring a regrading request form. For off-campus students, they should just email the form and the questions. So what is a regrading request form? It's a simple form which we require you to fill in order to give your request. Just quickly. So these are just the usual details, and then you have to explain what is the request type. You can have more than one request types, but in general you have to explain what are the reasons and what are you exactly looking for. This helps the grader to quickly deal with so many students, because there will be a lot of you guys there and it's just 2 hours. So it's important that you take the form with you. You could also email the form. It will save you the hassle of printout. The form is fillable, so you can just fill it out and save and
The
send
time is
it to the
19
graders.
o'clock.
There'll be only one form per student. Apart from the form or the office hours, the graders would not be able to entertain any emails regarding regrading, nor verbal confirmations. So whatever you need to do, just submit the form, because that will be used for official purpose later on, so that sometimes students just come back and say, we went for regrading and the grades were changed and never reflected. So that's why we started having these copies. So it's important that you bring the regrading form with you. This plot shows the stats for the homework 1 grades. The standard deviation is about 23. So there's a lot of spread on both sides of the mean. Overall, the higher side looks loftier. I would recommend that you start working harder so that the standard deviation reduces. That guarantees that everybody in the class performs good, because the grading is on curve. There'll be penalty for late homework, as Professor had mentioned in his first lecture. So, but he has not decided the penalty yet. And as a result of this, the late score might be decreased. So don't be surprised if your final raw scores are reduced. Now again, we are mentioning this because in the past we have experienced students would complain or won't be happy about it. So it's already known to you. So if you see a decrease in the late homework scores, it's a consequence of late submission. So if you have missing scores, if you can't see scores on DEN, just there could be 2 reasons for it. There were some plagiarism cases, so we are just evaluating them. We're just going through the cases. And there could be another reason for that. That would be some issues with your uploading. So when you uploaded the assignments, if there were some issues, the graders cannot easily reflect the grades back. So if you're not able to see your grades, just send an email to the graders and CC to us, and we'll respond. For discussion board, there are very good threads, 3 threads for FAQs for each of the problems. So please go through those threads and other posts as well before asking us any questions. You'll find detailed answers in those threads. So anytime, please stop me if you have any questions. First order derivatives, a lot of students have confusion between difference of Gaussian and derivative of Gaussian. I think in the lecture, professor had mentioned that first order method is DOG, right? That DOG is derivative of Gaussian. It's not difference of Gaussian. Why? Because what is the first order derivative method? You just take the first order derivative, apply it to the image, right? Then why do we apply the Gaussian kernel? To smooth the image. Why? To remove the noise, right? So basically, you're applying the derivative to the Gaussian filter, or the Gaussian filter to the derivative. It's interchangeable. Why? Because both the operations are linear, right? So that is derivative of Gaussian, and it's not difference of Gaussian. Okay? So basically, this is derivative of the Gaussian, and I can interchange the 2 operations in discrete domain because you're using convolution here, and it's a linear operator. What is Laplacian of Gaussian? It's this. First of all, what is Laplacian? Laplacian is the second order derivative, right? Then again with the same philosophy which you used for first order derivative, you want to use Gaussian kernel to smooth the image, right? That's why we use Laplacian of Gaussian instead of just applying Laplacian or the second order derivative, right? So again, this is a linear operator, so you can interchange the 2 operations. This Laplacian of Gaussian can be approximated by difference of 2 Gaussians. Okay? This is how usually a Laplacian function looks like. The Mexican hat, okay? So you can approximate it by taking the difference between 2 Gaussians. Either you could directly use Laplacian of Gaussian, or you could use difference of Gaussian, but doesn't matter. But don't confuse it with derivative of Gaussian. Okay? Again, remember that DOG is just an approximation to LOG. So you have to choose various values for sigma x, sigma y in both first Gaussian and the second Gaussian, for which of which you take the difference. The textbook details on how to select those sigma values or the standard deviations. So you can go through those notes. If you have any difficulties, let us know. Or simply you could apply LOG directly. I think we've already answered this. Can you interchange the operation of L and G? Yeah. You mean to say why use Gaussian and not a... Yes. Yes, you need to do that. What do you mean by standard Gaussian? There will be Gaussian functions which you already provided, so it will be 2D Gaussian. Just use that same equation and generate masks for different sizes of window required depending on what kind of mask you're using for edge detection. If it's a 3x3, 3x3 Gaussian, and so on. Yeah, so you need to normalize it. Just divide everything by the sum. So make sure it just sums to 1. Oh, actually, no, you might not need to normalize. Yeah, you shouldn't normalize, sorry. So just select a sigma which is good enough. I think professor discusses in class like what should be the standard deviation so that you can cover the region. So just do that. Or you could use standard DOG operators from the text. It gives you some masks, right? For problem 1C, the pencil sketch should be gray. It should not be black and white. I think there was this confusion earlier. So how do you get gray images? I'll just quickly discuss what is the basic approach. First, you need to obtain the derivative of the image. So when you take the derivative, you'll get the magnitude magnitude of the some squares of gx and gy, where gx and gy are the directional derivatives in x and y directions. So this will be the magnitude map. This can be also called as the gradient map. Using the gradient map, you generate a histogram of the values inside the gradient map, right? So for that, you need to quantize the values, right? Because gradient map values will be real numbers, right? They're not integers like your image pixel values, right? They're not integers between 0 to 55. They can be negative, they can be positive, and they'll be on a real scale, continuous, right? So you'll have to discretize them, right? So you can use uniform discretization process to discretize everything into or quantize the gradient values first, and then you can plot the map. Then using this gradient histogram, you have to find the threshold, and then you apply this threshold on the gradient map, right? So if you have a 0, if the value of the gradient map is below the threshold, you output 0. If the value of the gradient map is above the threshold, you output 1. And then, so with this operation, you obtain a binary image, right? Of the same size, which is of your original image or of the size of your gradient map, right? This is called the edge map. Usually in edge detection, you just give the output of the edge map. That is your edge detection output, right? But what you're required to do is create a pencil sketch, right? So you have to use this edge map information to create the pencil sketch. So for doing that, whenever you see a 1, in those regions, you can just output the gradient map, right? Yes, but those are your edge, that will give you edge map. With the 1s? So you just use those values in the gradient map. Operator, can I have the overhead camera, please? Yep. That is a different step you're talking about. You're mixing two things. That's a different thing altogether. That is when you're doing the transition, you have to convert the gray image into color image. It's just the image format. That is different. It's not, the image is not color in itself. It'll still be gray. So once you have obtained suppose you're not using the symmetric one, you're using T1 and T2. Okay? So you obtain, this is the 0 region. This is the, and this is your gradient map, right? So this will have like real number values. When you apply the threshold, you'll get right. So finally, you do pattern matching. or use a mask to find whether it is 0 or 1, right? One implies edge, right? So this is your edge map. And this is your gradient map. So whenever you have a 1, you can output the gray region from this image. It's precisely the same logic. It doesn't matter whether it's the edge map comes from the first derivative or the second derivative, right? Okay.
What about negative values in the gradient map?
Yes. So once you've selected the gray values, these are continuous values in the range minus infinity to infinity, right? So you can scale the image. Or 0 to 255. Can you not do that, right? That'll just look like an image. Or you can, in fact, scale it to even a smaller range, or depending on how you want to enhance your final pencil sketch image. Okay. Can I have the screen back on the computer? Morphological processing. I'm going through this again because there are a lot of students have doubts on this. So first you apply the conditional mask on your binary image, right? How do you apply the conditional mask? You just traverse the image with a 3x3 window and see if it matches any of the conditional patterns. Right? These are the conditional patterns. They are common for all the three operations, whether it is skeletonizing, shrinking, or thinning, right? Then you have two different tables for unconditional masks. And note that this table is applicable only for shrinking and thinning operations, and this table is only for skeletonizing operations. Please make sure you don't mix them up. You'll get the wrong results, obviously. So, sorry. Yeah, then you output just one in your intermediate image, which is the output of the first stage. You output one if you have found a pattern which is matching to the pattern of the current pixel. If it's not found, then you just output 0 instead. Okay? And in the unconditional pattern, in the next step, you match, you process this image, and you don't care about this image anymore, okay? So if there is a 1 at the center, then only then you process this, you apply the unconditional filtering to that location, right? So if there is a 0, you don't do anything at all. If there is a 1, then you find the pattern. If there is a match in the pattern, then you output 0. So you output 1 in the final image. And if you don't find the pattern, then you output 0. So basically what you're doing is at this stage, you already have reduced this binary image to a mask kind of image, which is also binary, which just marks the pixel, whether you want to remove them or not, right? Then in this stage, finally, you confirm whether you want to remove or not. And this 0, when you make 1 to a 0, that is the operation of erasure, right? So conditional filtering is straightforward. Just take a 3x3 mask, run over it, the entire image, find, give f hat 1 if there is a match found, 0 otherwise. And a very common mistake is people output the bond number. Just don't output the bond number, just write 1 there, okay? For unconditional step, again, as I mentioned earlier, just process if there is a 1. Make sure the tables are proper, using the proper tables. There's a typo in discussion number 4, slide 37. Sanjay has already sent out an email. I'm just reiterating it because we want to make sure that you're looking at the right slides, okay? So you can download the updated slides now again. So there are so many conditions to match, right? So how do you do it? I think I would rather discuss the sample midterm problems. There are various ways you can do it. This is just one of the ways. You can look at the slides later. It's very clearly described. Now this is the first sample midterm problem. You're given a 6x6 image and you're given a filter mask H, and you have to apply the filter. So this is a very numeric problem, very straightforward. You'll just have to do what you were doing in the coding and the same operation of convolution, and you have to do it by hand. Oh, sorry, I have the wrong. Okay, so it's it's a Sobel filter, so you have to do the Sobel edge detection. So first you apply the Sobel mask. So do a boundary extension. In this example, I just do it by zeros. It makes your calculations easier and it wouldn't affect the results as much. So if it is not stated in the problem, whether you're supposed to do it by zero or not, just use zero, it'll be convenient. And which of the two operators gives you a horizontal gradient and which one gives you the vertical edge? Oh, I've already given the answers. Anyway, so why is this horizontal gradient? It's very apparent, right? So the edge would be horizontal or vertical? Vertical, right? So just apply the mask, calculate at each point, and just give the output. So this is the first problem. For similarly, you get the vertical gradient. Then you just take the square of the values and sum them up. Then you just use a threshold depending on the directive in the question. So here I've taken the mean square gradient 254 as a threshold. So I think that's the problem. Finally, you have to apply median filtering. This is another problem. You have a low contrast image. It has both gradient noise and salt and pepper noise. So you have to develop a method to get a clear edge map of this image. So you'll have to state each step in detail. Comment on the differences between the edge maps that you will get from the first order and the second order edge detection methods respectively. So basically this tests, the second part of this question tests whether you're able to understand the applications of first order and second order and what are the different observations you make in your assignment. So while you're doing your assignments, the point of this sample midterm is when you're writing the discussions in the report, make sure you clearly understand what is the procedure and what is the effect of weighting different parameters or window sizes and everything, because the same discussion, same kind of questions could be asked in midterm problem, and most of the time the questions would be, the images would be very intuitive. So if you understand the process of your assignment, then you'll be able to solve the midterm problems. Otherwise, it will be difficult. Okay, so yeah, I think this problem is very similar. Like I've just written down what are the basic questions. So you observe the image, notice what kind of noises are present, and how do we handle each same kind of questions which you have already solved in the assignment. one thing I wanted to mention about homework 1, it was asked whether what kind of noises are present in each channel, and most of you gave the answer that salt and pepper noise is present in all the 3 RGB channels, whereas that was not the case. If you look at the blue channel, you'll see a peak at the 0. But isn't that peak obvious? Because if you look at the image, it's mostly green and red, right? So there'll be a lot of blue pixels which will be 0, right? So a lot of people mistook that as salt and pepper noise, and you've applied the median filtering that just worsened the situation. So just be careful with when you look at when you do the midterm problems. Yeah, this is something which you'll be able to fill in the gaps after you've already done this assignment. Now, since we have time, we'll go back to. No. Right on the questions. It could be open-ended questions or questions like this where you have to do the things manually which you've been doing in your program. Yes. Yes. We'll give you tables and a lot of space. Don't worry about that. So okay. So I'll come back to this. So there's so many logic operations. So how do you do it? You can convert a 3x3 mask into 8 bits of digits, right? And you can finally convert them into decode them as from base 2 to base 10, right? Then you just need to match the numbers. So for all of the masks, you can just find out the corresponding number. So the moment you write a code for this, it'll be very easy to convert the entire table into just integers. And whenever you're doing the processing, same way, it'll be very easy. So this is just an example. So this comes out to be 40 in the decimal base. So this is an example for the unconditional mask. You convert the mask as well in the same order. Just make sure you keep the order consistent everywhere, right? So now for M, what is D, M, A, and B? If you look at a mask, so D is either 0 or 1. A, B, C can be 1. Any of them has to 1. At least one of them has to be 1. So all the 3 possibilities have been covered, right? D, 1, 1, 1, D, zeros, and the combinations of M. How many possibilities for M? 1 everywhere. Why? Because if it's not 1, then you don't process it, right? So M is 1, and you ignore the center pixel, and then zeros as it is, A and B, all possible combinations, A, 0. The only combination which would not be here would be both zeros, right? And this would be an OR operation, right? Finally, let's look at for problem 2, in this image, there are stars of various sizes. So a star is just defined by a continuous region of whites. Can I have the overhead camera? the question is about the radius now, or the size, sorry. I think in the discussion, in the assignment, in the lecture, professor had discussed something about a lot of stars together. I would say don't take that approach, because what we are looking for is the size of the individual stars. Okay? How do you define the size of individual stars? Number of iterations to make it completely disappear, right? So what we are looking for basically is a histogram. This will be like number of iterations. And how many stars would disappear after, say, one iteration? Okay? So this is what is desired. Excuse me. If you have overlapping stars, you would not be able to distinguish between them with them algorithmically, so you can just consider them as one star. Because the shrinking operation, would it break the stars? Right? It wouldn't. So it'll just converge to a point where have you observed such cases? If you do find something like that, then you'll have to fill the holes. Excuse me? So you can create a mask. Design your own masks to fill the hole.
When you say white, you mean 255 or you like use some kind of threshold?
For the stars?
Yeah.
You can use thresholds to convert it into a binary image.
Okay, so like when you're testing for white, it's not necessarily like a pure white.
Excuse me. Which stage are you talking about? After you have to first convert it into binary in any case, right? Otherwise you can't. Yeah, because you cannot apply the morphological processing until it's binary. So the first step is converting it to binary image. Yes, so as a result of that, it might happen that you might end up with stars with holes inside, depending on how you select the threshold. So in that case, you need to fill the stars. Because if there is a hole, then what will happen if you do shrinking operation? What will happen if there is a star with a hole in it? You'll just get a boundary circle, right? Somewhere in the middle of the two concentric rings. So that kind of output is wrong, and a penalty will be applied for such kind of outputs. So you'll have to fill the holes. You can just design some binary masks. To detect whether there are holes or not. These don't have to necessarily be 3 by 3. And one more thing, if you find anything going wrong with your thinning, skeletonizing, or shrinking operations, some of the masks might be missing from the table. When I say missing, the tables in general should be complete. It should not happen that your thinning operation is breaking or your skeletonizing operation is breaking. But if it does happen, then in that case, there are two options. One, you just discuss what is happening, but you have to analyze why is that happening. Like suppose if a straight square is breaking into 2 lines for thinning operation, then you need to find out at which iteration it is breaking and why is it breaking, because obviously it's erasing a pixel which it's not supposed to erase, right? So you need to find out the mask which is missing from the table, and you need to explain this phenomenon. You could design the mask, that is the second thing, but that is an option. But the necessary portion is to identify the missing masks, okay? As far as we are concerned, when we implemented, or the TAs implemented the assignment, there were no missing masks. But if you encounter something like that, okay? Can I have the screen back on the? One thing again I have to clarify, these are not, the larger ones are not the point balls which we are talking about. I think in the lecture, Professor by mistake mentioned that these are the balls, right? So the point balls are these smaller ones, okay? The larger one is not the point ball. So you have to distinguish between the two. So you cannot count the larger one. Is that clear? Okay. Do you have any questions on half toning? Anyway, I don't think anybody's told me this. So that's all I have. Okay. No. Do you want to do that? You can't do that because you haven't done optical character recognition yet. So yes, you just have to count the digits. And there's one special case in this, that is what happens on the boundaries. So if you notice, there'll be partial digits on the edges, right? So we need to know how you're handling them, and you have to handle them, okay? So that is one thing which you must take care of in this problem. Everything else is pretty much straightforward. Okay, that's all for today, if you don't have any questions. Thank you.
And this concludes EE 569 on Tuesday, October 1st, 2013.